All right, this is CCS 447 Project 2 Part 1. I started in the Lab 11 Uvision project. Um, all right, so let's go ahead and go into the main code here. This UART file is exactly the same, just really quickly. It's exactly the same as it was for Lab 4. Didn't see any need to change the UART for Part 1, so I kept it the same. And then going into the main code here, I have assigned some values for different GPIO ports. Just set up port F. Sorry, not different ports, but just setting up F. And then I defined specific locations for the switches, for switch 1, which I'll be using for PF4, and switch 2, which I'll be using for PF0. And then including some things here, the UART, the speed rate for the port on my computer, which will come up later. Texas, PLL, some pretty standard stuff. Boolean, which I'm currently not using, but was going to use. Some different variables here to store information, function prototypes, subroutine section, which is where my main is stored. So the main function's almost identical to Lab 4. You disable the interrupts, set up the port F, the PLL, the UART, the GPIO interrupt init, which handles the port F interrupt for the onboard switches, dual edge detection, and then enabling interrupts again, so that way everything's all turned back on. And then here's my main loop. In the main while loop, you take the input from the UART char, and then you do something with it here based on the switch case. If it's an R, G, or a B, it's going to respectively do red, green, or blue, setting the GPIO port F data values, which turn on the LEDs. Else, you're going to get a 0 and an input error, meaning that you didn't follow the instructions. Port F init, these are just pre-standard here. Establish a delay, give it time the clock to set up, unlock the port F, disable analog function, GPIO clear bit for the port control, yada yada yada. PF4 and PF0 are the important parts here because those are my inputs from the onboard, and then PF3, 2, and 1 are your onboard LEDs located here on the board. And then moving down, we have the general interrupt here for the port F. Here I made some comments enabling PF0 as level sensitive. Both edges, clear flags, arm interrupt, priority 5. A lot of that's not super important just because I don't have a whole bunch of stuff conflicting with it, so it's just sort of running as is. Here's the handler. The handler is pretty straightforward. It clears the flags for the ICR, interrupts service routine, and then I take an in value and I basically take my switch 1 button and I set it equal to the second bit, and then my switch 2, since it's negative logic, I flip that one, and then that one is going to be my first bit, and then based on the bit values, we're either going to, if it's the first switch on bit 1, we're going to have all the LEDs turned on. Otherwise, if it's the first bit on switch, the second switch, then the LEDs are going to be turned off. And then there's a little delay in there so that the handler doesn't get called too many times. Sort of a pseudo debounce for my setup. And then comments here for the different colors that could be produced based on what configurations you do on the super LED here. And then just a little delay down there at the bottom, which I'm using to sort of pseudo debounce the button press. And then, all right, so let's go ahead and go into the code here. So I have, oh, that's not, well, it doesn't matter. So I had been testing it here, but we're going to go ahead and build it. And then we're going to load it to the board. As you can see, the board is fresh here. Nothing, no funny business. And then we'll go ahead and click here on the port. And then we're going to go ahead and, so what we're going to do is we're going to go through RGB. We're going to press R, which then we look at the screen, it says our red LED is on, and then we look at the board, we got a red LED. Then we're going to do that for the green. Pressing the G. Sorry, you didn't see me press it. Pressing a G, so I pressed it twice there. And then green color. And then we're gonna go ahead and press the B button here. Boop. And then there it is. The blue LED is displayed to the UART through the terminal. And then there's that blue LED there. Now we're going to go ahead and press the first switch, which turns all the LEDs on, which makes it look a white color here, which again, all the LEDs have been turned on. So all 3 individual LEDs inside the larger LED have turned on. And then when we press the second switch, the LEDs go off, which is in fact what gets displayed here to the screen per what was written in the code. And then that's the completion of part 1 for project 2. I hope you like my code.